P0302 is a cylinder-specific misfire code. On this F-150 with the 2.7 EcoBoost, the truck may run rough, stumble under load, idle unevenly, or set the light when the PCM sees uneven crankshaft acceleration from one cylinder. The cause may be ignition, fuel delivery, an air or EGR issue, base engine condition, crank signal quality, or even electrical noise. The right move is to keep the diagnosis structured and prove which system is actually causing the miss. Start with the basic system checks. Pull codes first and make sure P0302 is the code you're chasing. If other codes are present, check what they mean first, because some codes change the diagnostic path. Before clearing anything, save the PCM freeze frame data. Clearing PCM codes erases that captured data, and you may need it later to reproduce the conditions that set the misfire. Compare the recorded freeze frame PID values to the normal reference values for this engine. If something is out of range, stop and follow the correct data-driven path, instead of forcing the misfire routine forward. If the values look normal, continue into the mechanical and contribution checks. Next, run the relative compression test. If that scan tool test is not available on the vehicle, treat it as a pass and keep moving. If a cylinder does not pass, follow up with cylinder leakage testing on the suspected cylinder, and if needed, a compression test, before blaming ignition or fuel. Once compression checks out, turn the key on and look for non-misfire continuous memory codes, then KOEO codes, then KOER codes. If any of those are present, diagnose that next code first and set P0302 aside for the moment. If none are present, keep going. Run the cylinder power balance test. If that scan tool test is not available, treat it as a pass. If all cylinders contribute correctly, skip ahead to injector flow. If contribution is not correct, move into ignition. Do not disconnect a coil on plug while the engine is running, because that can damage the coil or the PCM. Also keep in mind that ignition faults can raise catalyst temperature, so look around the catalyst and muffler area for heat damage if the miss has been severe. In the ignition branch, confirm the misfire code or the symptom is still present, then run power balance again. If all cylinders contribute correctly there, do a visual ignition inspection before getting deeper. Make sure the coils are fully seated and connected. Look for damaged, burned, or overheated wiring. Check for loose or broken connector conditions. Keep the battery in good condition and turn accessories off. If a visual concern is found, repair it, clear the PCM codes, and repeat the self-test. For the suspect coil, key off, disconnect the coil connector, key on, and check VPWR at the applicable coil connector pin. On this engine, the VPWR check must be greater than 10.5 volts. If it is not, repair the open power circuit. Clear the PCM codes and repeat the self-test. If VPWR is good and P0302 is the cylinder-specific misfire being diagnosed, the path goes to spark testing for the cylinder indicated by the code. If the path is not tied to one cylinder, use the all-cylinder spark check instead. On this 6-cylinder engine, use the bank logic to decide whether the concern is on bank 1 or bank 2. P0302 is on the bank 1 side. If the diagnostic pairing calls for a bank-to-bank component confirmation, move the suspect coil, spark plug, and fuel injector with the matched opposite bank components. Reassemble the vehicle and drive it to see whether the misfire moves. If that pairing is unclear, pause, recheck the earlier diagnostic path, and avoid guessing. For the P0302 spark check, key off, remove the fuel pump fuse to disable the fuel pump, disconnect the coil from the plug, connect an adjustable ignition spark tester THX 458 or equivalent to the coil boot. Set the tester to 40 kV, crank the engine 3 times, then set it to 25 to 28 kV and crank while watching for spark. A good ignition system only needs to prove spark in that 25 to 28 kV range. If there is no spark on this 2.7 EcoBoost, install a new coil or cop, clear the PCM codes, and repeat the self-test. If the path calls for checking all cylinders, use the same setup. 40 kV first, crank the engine 3 times, then test at 25 to 28 kV while cranking. The next component inspection in that ignition branch applies to a different engine family, so on this 2.7 EcoBoost, there is nothing to apply there. Continue to spark plug inspection. Inspect the spark plug for damage, wear, carbon tracking, deposits, and correct gap. If the plug is not okay, repair it, adjust the gap, or install a new spark plug as needed. Then clear codes and repeat the self-test. If the plug looks okay, measure resistance from the center wire to the terminal. It should be between 2,000 ohms and 12,000 ohms at a room temperature of 25 degrees Celsius, 77 Fahrenheit. If it is outside that range, install a new spark plug, clear the PCM codes, and repeat the self-test. If the ignition checks pass and this branch was entered from the power balance step, return to injector flow testing. If you did not enter ignition testing from that path, treat the concern as intermittent and do not guess. Now run the relative injector flow test. If that scan tool test is not available, treat it as a pass and continue. If all injectors are flowing correctly, move on. If one is not, check for a loose connection or damaged or corroded pins, repair what you find, then continue. After that, check the fuel system through the fuel system diagnostic path. If a fuel system concern is found, repair as needed, clear the PCM codes, and repeat the self-test. If no fuel concern is found, continue to the air and EGR side of the diagnosis. Visually inspect the vacuum hoses for damage, deterioration, or restrictions, and inspect the EVAP lines and hoses for wrong connections or damage. Some vacuum leaks can be heard, but still inspect the hoses closely. If you find a concern, repair it, clear the PCM codes, and repeat the self-test. If the vacuum side is clean, start the engine and bring it to normal operating temperature. On the 2.7 EcoBoost, monitor the EGR VPDES %PID at idle, then key on with the engine off and record it again. Compare those readings to the normal reference values for this engine. Not every PID is available on every vehicle. If an EGR value is out of range, diagnose the EGR system. If the EGR data is in range, key off, disconnect the EEGR assembly connector, then try to recreate the misfire using the freeze frame and customer information. The vehicle may need to be driven to reproduce the original conditions, and the PCM may store EGR-related codes during this EGR-disabled check. If the symptom can be recreated, continue to base engine checks. If it cannot be recreated, remove and inspect the EGR for contamination, unusual wear, carbon buildup, binding, or other damage, repair as needed, clear the PCM codes, and repeat the self-test. With the key off, check base engine integrity. Look at any mechanically driven cooling fan if equipped, inspect the accessory drive, run compression and cylinder leakage testing as needed, check valve train operation, inspect the PCV valve and tube for leaks, use the appropriate engine component tests, and inspect IMRC linkages if equipped. Engine temperature can affect the results here, so be aware of when the fault happens. If you find a base engine concern, repair it, clear PCM codes, and repeat the self-test. For P0302, if no base engine concern is found, move to the suspect fuel injector check. Start the engine and use the injector disable PIDs if the vehicle supports them. Command the suspect injector off. If engine RPM changes, move on to the crank and noise checks. If engine RPM does not change, inspect the suspect injector connector and pins for damage, corrosion, or incorrect connection. If the connector and pins are okay, install a new fuel injector, clear the PCM codes, and repeat the self-test. There is also a cam position sync checkpoint in the shared misfire path. If earlier code results send you there, start the engine, monitor the sync PID, and if the CMP sensor appears out of synchronization, verify correct CMP sensor installation before continuing. Next, check the generator for excessive electrical noise. Start the engine and listen for audible electrical noise from the generator. Then key off, disconnect the generator or regulator B+ connector, restart the engine, and see whether the noise changes. If the noise stays constant, continue. If the noise decreases with the B+ connector disconnected, diagnose the generator noise concern. Then inspect the CKP harness for damaged wires or physical damage that could cause an intermittent short. If you find damage, repair it, clear codes, and repeat the self-test. If the harness is okay, inspect the crankshaft pulse wheel for damaged teeth, wobble, or looseness, inspect the crank pulley for wobble, and inspect the CKP sensor for damage. If those parts are not okay, repair as needed, confirm correct CKP sensor installation, reset KAM, and run the misfire monitor neutral profile correction with the scan tool. If the crank sensor, pulse wheel, and pulley are okay, check for biased oxygen sensor data. Start the engine and monitor EQ RAT 11, EQ RAT 21, long FT 1%, long FT 2%, SHRTFT 1%, and SHRTFT 2%. Record the values and compare any that look out of range to the correct reference values. If the data points toward a biased HO2S, check the HO2S, exhaust system, and HO2S mounting flanges for leaks or damage. Repair as needed, clear codes, and repeat the self-test. Finally, look at recent repair history. If rotational engine parts or front accessory drive components were recently replaced, run the misfire monitor neutral profile correction. Recreate the original conditions from the freeze frame and customer information. Monitor cylinder misfire data in mode 6, onboard test results, and verify the misfire count is below 10. If the diagnostic path calls for the road test distance, use 5 to 10 miles. If the misfire still is not resolved, stop and continue with the intermittent diagnostic path. Keep verifications separate from testing. After any repair, clear the PCM codes, repeat the self-test, and reproduce the operating conditions that set the misfire. The takeaway is simple. For P0302, do not jump straight to parts. Prove mechanical condition, prove contribution, prove ignition, prove injector and fuel delivery, then check air, EGR, crank signal quality, sensor bias, and recent repair history in order. For more diagnostic training, visit stepdiagnostics.com.